Hello everyone, and welcome back to the maths. In this video, we are going to learn about inverse function. If you haven't watched the videos regarding domain and range function or about composite function, you can try to take a look at the function playlist which I have attached in the top right of this video. Now, let's try to review a bit what we have known so far. So we know that a function is something that relates an input to an output. Now here's the thing though. Is there any function that can relate the output to the input? So when we try to plug in the output values, we get the input values. There exists such function actually, and that function is called the inverse function. And the symbol is usually f to the power of -1x. Now, I want to clarify a few things before we get deeper into this. The first one, f to the power of -1 is not 1 over f of x, because you might notice that in exponential, negative power means the reciprocal. But this is not the case for a function, so please remember that, okay? Now the next one, I want to talk about the domain and the range of a function and an inverse function. So, like we know, a function is something that relates an input, or domain in this case, to an output, or the range. Now, inverse actually means opposite, right? Inverted, which means the output, the original output that we have, is now the new input. Remember, inverted, right? So the old output becomes the new input. And then the original input of our original function becomes the new output. So we now have a simple diagram so that we can memorize. Old input becomes new output, old output becomes new input. So I think this one is easy to memorize, I believe, yeah? Right, the next thing that I want to tell you guys is that f inverse, so the inverse function only exists if the function is a one-to-one function. Let's try to review a bit what is a one-to-one function. So a one-to-one function is a function that has one output for one input and one input for one output. You can also say this as 1y for 1x and 1x for 1y. An example of a one-to-one function is going to be like this. So as you can see, 1y corresponds to 1x and 1x corresponds to 1y. This is a one-to-one function. Next one is the one-to-many function. So one-to-many function means that one output for one input. This one is the same as before. And then many input for one output. Now this one is different. You can also say that this means 1y for 1x and many x for 1y. You might be confused at the wordings of this, but let me try to give you a graph that shows one-to-many function. It is a familiar graph, a very familiar graph, which is a quadratic function. Because we know that 1y is for 1x. 1x value can only have one y value, right? But one y value can have many x value. As you can see, one y value in the parabolic function has two x values, x on the left and x on the right. This is a one-to-many function. Now, like I said before, the inverse only exists if it's a one-to-one function. Now here's the case though. If the function is a one-to-many function, just like the quadratic equation or the quadratic function, does that mean we cannot find the inverse? Now let's try to see the answer for the question, okay? So we know clearly that a quadratic function will have no inverse function. But what happens if I try to make it like this? Let's say I try to cut the quadratic function like this. Now, as you can see, it's a one-to-one function because 1y for 1x and 1x for 1y. So that means this part of the function has an inverse. I can also try to cut the quadratic function in a different way. I can try to cut it like this. So I try to cut it in half and I have the left side as the leftover. Now this one is also a one-to-one function, as you can see. And this one has an inverse function. So what's the conclusion in these two cases? For a one-to-many function, you can find the inverse if you restrict the domain. So you can only find the inverse for a partial part of the quadratic function, and that's okay. That's no problem. Okay, so you cannot actually find the inverse of the full thing, but you can actually find the inverse of like some parts of it. Okay, now let's try to get into the examples. For this one, it's going to be very easy. We need to find the inverse function of this linear function. The first thing we are going to do is we can substitute the y with the f of x. We know that y and f of x means the same thing, but it's going to be easier if we try to work with the y, okay? Now, the next one is the most important step when we are finding an inverse function, which is we need to interchange the x and the y. Now, you might be wondering, why do we need to do this? Remember that in an inverse function, we swap the domain and the range. The input becomes the new output, and the output becomes the new input. The old x becomes the new y, the old y becomes the new x. That's the reason why we interchange the x and the y. So that means the next step is going to be like this. The output becomes the input becomes the output. That's the essence of inverse function. The next step, guys, we have to make it such that the y is on the subject. Basically meaning we make the y in one side and x on the other side. So we can try to make it such that the y is on the left side, let's say. It's going to be like this. We do a little bit of algebra and we know that y is equal to x plus 2 over 5. Therefore, we know that the inverse function is y equals to x plus 2 over 5. But remember, we are not done yet because we need to replace the y with f minus 1x. This is the final step and we cannot forget this, guys. So we now know that the inverse function is going to be x plus 2 over 5. Pretty simple, right? Right. Let's try to see the next example. So now we have a rational function defined for any real x values, and x cannot be equal to -4. So how can we find the inverse function? Simple, yeah? We just have to use the method we used before. So first, we substitute f of x with y, and then we interchange the x and the y, which will look like this. Now, we can make it such that y is the subject. Now, usually, if this is the first time you're learning about inverse function, you might be confused on how to make y the subject. Or let's say that you are confused on how to isolate the y on one side of the equation. So the easy step to do this is to multiply both sides by the denominator. Or you can cross multiply it. So it's going to be like this. X times y plus 4 is equal to 2y minus 1. And then you can try to expand the left side. After that, you can gather all the y on one side, which will look like this. So xy minus 2y is equal to minus 4x minus 1. Now, next step, you can try to factorize the y, and then you can try to move the x minus 2 into the denominator of the right side, which will look like this. And now we have our inverse function. But remember, we are not done yet. We have to replace y with f to the power of minus 1x. So this is our inverse function. Now, how can we find its domain? It's going to be very simple. We just have to take a look that this function is actually a normal function, just like the one in the problem. You can say that it's going to be defined for any real values. It's just that the denominator cannot be 0, which means x cannot be equal to 2. So this is the domain of the inverse function. Okay, so on this example, it's going to get a bit difficult, but I think you can still try to understand this. So we need to find the inverse function of a quadratic function, x squared minus 4x, defined from 2 to 6. Now in this case, I have already defined the domain such that this is a one-to-one function, okay? So the first step, just like what we did before, we can substitute f of x with y, and then we can try to interchange the x and the y. So it's going to be like this. X equals to y squared minus 4y. And then we need to make it such that y is the subject. Now, you might be confused on how we can isolate y on one side such that you only have one y, not two y in this case, yeah? And you can do that by completing the square. So you can try to complete the square on the right side, and if you forgot, I'll put a link of the video on how to complete the square in the top right of this video right now. And let's try to continue with completing the square. So this is the form that we got after we complete the square. And then we can try to move the minus 4 into the other side. So it's going to look like this. And then we can try to take the square root. So it's going to be y minus 2 equal to plus or minus square root of x plus 4. Then we have our inverse function. But wait a minute. As you can see, we have a plus and minus sign. Which one is correct? Is it the plus or is it the minus? Okay, so to check which one is true, we can first state the coordinates of the original function. I will say this as the old coordinate or the original coordinate, whatever, it's okay. So if we try the boundaries of the original function, let's say that x is equal to 2, it's going to be minus 4. And if x is equal to 6, it's going to be 12. And then we need to remember, in an inverse function, the old input becomes the new output. The old output becomes the new input. What I'm trying to say is that for an inverse function, you just need to flip the x and y value. You just need to flip the x and y value so that it looks like this. So now the new coordinate, the coordinate in the inverse function is minus 4, 2 and 12, 6. Now, here's the thing. We can try to test these two alternatives because we know that in the inverse function that we got before, there is a plus minus sign, so we just have to separate it. So we have the first one which uses a minus and the second one which uses a plus. After this, we can try to test the function. How can we test these two functions? Simple. We just need to input the x values that we got from the new coordinate. So the new coordinate says that if x is equal to negative 4, the y should be equal to 2. Now, is that correct in the first function? It is. How about the second coordinate? If x is equal to 12, it's going to be minus 2. So these are the coordinates that we got. Unfortunately, it's not the same as the new coordinate that we should be getting. So this one is not correct. Therefore, the correct one is the other one, which is the plus sign. So if we try to use the second alternative, which has a plus sign, if x is equal to negative 4, y is equal to 2, same thing. But if x is equal to 12, we know that y is equal to 6. So the coordinates that we get is the same as the new coordinate. So therefore, yeah, this is the right inverse function. So the inverse function, f inverse equals to 2 plus square root of x plus 4. Okay, so we are going to use the exact same function, but in this case, we need to find the domain and range of function. Now, here is something interesting. To find the domain and range of the inverse function, you don't need to find the expression of the inverse function. Yeah, you don't need to find the expression of the inverse function because we can try to remember that for a function, it basically uses the old domain and make it into the old range. So the old function will make the domain into the range, and then, as we remember, in the inverse function, the old range is going to be the new domain. And then the old domain is going to be the new range. So we just have to flip the domain and the range, and we are done. Let's try to list out the domain and the range of the original function. So the old domain, which is from 2 to 6, and the old range is going to be from -4 to 12. And as you can see, old domain is equal to the new range. So you just have to switch the x with the symbol of f inverse x. Simple, right? And for the old range, it's going to be the new domain. So now you just have to switch the f of x with x. So now we have the domain and the range of the inverse function. So there you go. The domain is from -4 to 12, and the range is from 2 to 6. Okay, now let's try for our last example. In this case, we have also a quadratic function, but the domain is still not clear, from a to 9. And we need to find the smallest a value such that the function has an inverse. Okay, let's try to remember. A function only has an inverse if it is a one-to-one function. Okay? So let's try to sketch the quadratic function. It doesn't need to be perfect. It doesn't need to be near perfect. It can be just like a rough sketch. It's okay. And then let's just say that x equals to 9 is over here. Okay, let's try to think of this a little bit. I want to find the smallest a value such that this function has an inverse. What is the easiest way that we can cut this quadratic function such that it is a one-to-one function? Any ideas? So the best idea to do this is to cut the function in half. And what is the line that bisects the quadratic functions symmetrically? It's going to be the line of symmetry. And the point in the line of symmetry, as we know, is the vertex. It is the vertex. Therefore, the smallest a value is going to be the x-coordinate of the vertex. The smallest a value is going to be the x-coordinate of the vertex, and therefore, we can know directly that the smallest a is going to be 3. Simple, right? Right, so these are the exercise that I've prepared for you guys, and as usual, the answer will be in the description box. Right, so that's it for this video. In this video, we learn about inverse function. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.